made a lot of changes over the last couple weeks. Several weeks ago, we put some fire extinguisher bodies here and we delivered them into the blade. You can see some of the residual effect. This is one of many dents. We also found that we destroyed a piece of just under 1/4 inch steel plate, and instead of refilling these with the crumbled concrete, which is what we've used elsewhere, we just filled the entire volume with Doug fir 2x4s, so with fiber. We have a GoPro, which is doing 240 frames per second, and we've added this camera, which is doing 1,000 frames per second. We're expecting this motor to be able to push the blade from the current RPM of 1,700 to a projected RPM of at least 2,400, and that will match the spec, the maximum allowable rotation speed of the blade allowed on BattleBots. So even though we're only picking up about 700 RPM, we're going to nearly double the amount of kinetic energy that's stored in the blade. Funny thing about this type of conductor, about SO, is I think they use like baby powder or something inside it. So it's like you peel open the cable and you're like, why do I feel like I'm changing an infant? We changed the size of the pulley here. Then we put a VFD, a variable frequency drive, in line so that we can program the ramp up and ramp down of the motor. And then we shock mounted all of the electronic components, all of the sensing equipment in the VFD, such that it will be a little bit more immune to impacts, because we've been rattling it around and we've been damaging a lot of equipment. The next thing we're going to do is mount a piece of polycarbonate right here. So we've got a piece of 1.25 inch polycarbonate, and we're going to drop it into some brackets on top of what we're calling the backstop. If I remember correctly, it's bulletproof to a little bit over a 38 round. I think it's bulletproof to about 9mm round. So we can reasonably expect that this will protect the electronics from small high velocity debris.
So this is our big red button box. It is, instead of using just some software to control things, we made some hardware. So, ta-da! So, we've got power, so we enable the device. So the yellow will now, and actually Rusty's out there, so enables the pneumatic ram. So when I push the big red button, the pneumatic ram will actually fire. We can fire that with or without having the blade spin up. And when we turn on the red, we get the blade spinning and the pneumatic ram ready, and then we can push the big red button to fire it all.
We're about to spin the blade up again. So we have an 80-pound blade on a 10 horsepower motor that will be doing 2,400 RPM. Part of what we're trying to figure out is how much of that impact will transfer from the blade to the object. Just to give you a sense of what we're expecting, we ran a little bit of math, and you can anticipate this as roughly a Ford F-150 being dropped from about 8 feet, or this 40-pound object being dropped from a height of roughly a 1/4 mile, or the same 40-pound object moving at a speed of about 200 miles per hour. That's how much kinetic energy is involved. We're not certain as yet how much of that will be transferred in the final impact, but we're gathering data to make that assessment. We have a 71-pound radiator. Matt picked it up at auction. So this is one that we think will be kind of dramatic. We're not going to necessarily get a lot of armor data out of the impact, but we are going to get a good sense of how this material behaves in a massively kinetic environment. was a 71-pound radiator. It's probably a lot smaller pieces now. I'm not sure what kind of dust I'm smelling. So it kind of like, it hit it hard enough to more or less turn it into like shot pellets.
Just little, yeah.
like
It is
dust.
all sorts of sizes, right?
I mean, this was a good specimen of cast iron. Like this was, it was made correctly, so it was about as strong as it was going to be.
Yeah. Look at that. Yeah, it's actually, I'm surprised that, like, it got destroyed,
Yeah.
but not as much as I would have necessarily expected.
Well, we threw a radiator into the blade, and as predicted, we got a lot of tiny little pieces, but we did verify that the weapon is working, their systems are working, and our cameras are operational. So the next time we come back, we will have 3 armor tests to record and share with you.